What's up, Phil? What are you gonna eat? Something that you hunted? I know you have stuff in the fridge from your hunting expeditions. Oh, hey, Sean. Good to see you. Good to see you. How's work and everything? Hello, Jav. Oh, you get to apply stuff from digital to your work? That's good to hear. Ooh, that sounds like a good dinner. How's the family, Jean? Glad you enjoy the music feed. How old is your daughter? I love metal. And Lamb of God was one of the, it's one of my favorites. My family's good as well, Jean. It's just me and Hannah. I think we're still a few years away from taking the plunge into having kids, but... That is BB-8 in the background. It's a little BB-8 alarm clock. Hey everybody. You didn't miss anything, Toaster. Engineering is nothing without a little vibe. I couldn't agree more. How's your Monday going, everybody? So far, so good. We'll get started in a couple minutes. So the human body can last about 3 days without water and on average about a week without food. Wait, why are you looking that up? Oh, but it turns out if you have a classically Jewish... I don't get it. I don't get it. Internet was out today and it was rough. Hey, hang in there. All right, it's 7. Whoa, what is this text on the bottom of the screen? Let's just get rid of that. People who take care of chickens are chicken tenders. Wow. Potato, good evening. What about the people who eat the chicken tenders? I'm one of those people. I'm one of those people. All right, we're moving from the acoustic jams to the chill electronic jams. All right. You guys ready to talk about Workshop 2? Where should one perform math operations in the Arduino IDE? Well, that can happen like anywhere in your script. No FF7 tonight? Maybe later. Oh man, I love Final Fantasy VII music. Or just Final Fantasy music in general. So happy with it. iMorse, what kind of math operations are you talking about? Because there might be some math that you want to do in your loop, for example. Yes, a man of culture. All right, I'm opening up Workshop 2. Dividing the ADC into 4 portions. You know, you don't even... iMorse, you don't necessarily have to do that in the Arduino. Like, let me tell you what I'm talking about. I mean, we'll get to that a little bit later, but let's address this right away. So one of the final exercises is you want to turn on different LEDs depending on where we turn our potentiometer dial. And so I want you to divide the 0 to 1023 range into 4 sections. So it's kind of like evenly distributed. When you turn the dial, it'll turn on one light, then the next, then the next. Well, like those numbers associated with dividing it into 4, they're going to appear in like an if-else statement structure. And if you just have to substitute those numbers into this structure, you don't have to calculate what those numbers are in the Arduino, you know what I'm saying? You could calculate that offline just in MATLAB or just using a calculator. I don't know if that answers your question, iMorse, but I don't do that division of 4 portions in the script itself. This workshop is fun, in my opinion. It has some fun results. Basically, we're reading some... Also, wait, iMorse says, if the ADC doesn't read values in between integers, can we actually mathematically divide the signal into 4 equal parts? Well, roughly. I mean, you can figure out what the points would be where the exact division into 4 sections takes place. And then you can round, and it'll be effectively equal. We don't have to split hairs over that. Yeah, sure, round up to an integer. That's cool. All right. Why don't we start with building... You're welcome, iMorse. Let's start with building this first circuit. And then we can talk about it. Let's bring it over here. So the first couple exercises use this. It has a photoresistor up here. Your photoresistor looks like this. Where's the photoresistor in the kit? I can't find it. It's not with the other resistors. Like, it was in a little different envelope for me. So just look through all the different plastic envelopes and you'll find this. I think there's 2 of them in the kit. It's kind of cool, huh? Oh, it's with the buttons? Okay, cool. All right, so I'm just gonna start plugging things in. Zoom in a little bit more. I'm just putting the photoresistor in first. So one leg in the top row, another leg in the third row. And then you're gonna need a 10 kilo ohm resistor to go in series with this. So if you go into your resistor bag, find the one that has the 10 kilo ohm listed on it. So far, we've only used 1 kilo ohm resistors, and we're gonna use plenty more of those tonight. But we're gonna put the 10 kilo ohm resistor in series with the photoresistor. So I'm gonna put that in I'm gonna have one leg in the same row and the other leg just somewhere further down. All right. I'm gonna take one little red wire, attach it in this top row. So it's gonna be in that same row with one leg of the photoresistor. And I'm gonna take a longer yellow wire and attach it also in this third row. So it's going to be the third row here is going to have one leg of the photoresistor, one leg of the 10 kilo ohm resistor. And then this yellow wire is going to be going to analog input 0. All right, let's go back over here. Okay. I'll put a short blue wire in this last row with the second leg of the resistor. And then I'm going to bring it in over to this negative column on the Arduino board. And we'll connect that to ground. Actually, how would we do that right now? Let's take this negative row of the breadboard. And it's kind of arbitrary that we call this negative. It's kind of, because you could make it a positive if you wanted. You could plug power into that negative row. It's just convention that we use it for negative. I mean, it's labeled that way, so we might as well just put it to our use so we don't forget. And then remember, there's labels on the side here, so I can be sure that I'm plugging into the ground. Okay, so I got that. This photoresistor's plugged in. Where's this red wire going? Oh, we're going over to the power block over here. So this top end of the photoresistor, we're going to the power column. And I'm going to take a long red wire and take that power column over to the 5-volt pin on the Arduino. There we go. I can look on the side too. Focus. But you can see that's going in the 5-volt. This other one's going in A0. And I think that's all we're gonna need for the photoresistor. Let's see. Yeah, that's kind of like part 1 of this circuit. And this is actually all we need for the first exercise. So there's a sample code on UB Learns. What is it called again? Photoresistor voltage divider. .io. So you can find that on UB Learns. I think I have it open already. Yeah, it looks like this when you open it. So as long as you have all the photoresistor stuff hooked up, you can move on to this. So I'm going to plug in my Arduino via USB. I'm going to go to Tools on the Arduino IDE, and then you go to Board, and you make sure it says Arduino Uno, because that's what we're using. And then you should have Port. Your Arduino Uno should show up. Hopefully this week, some of these annoying bumps in the road of just being able to upload to your board, hopefully we've overcome those things. Are 1 kilo ohm and 10 kilo ohm resistors in the same bag? Yes. Yes, they are. Could you find it? Remember, they're all labeled kind of with some faint ink on the bottom of the paper. All right, so I'm going to upload this. Let's go. Now, the point of this script is mainly here. We're using the analog read command. So we talked about this in lecture on Friday, but this yellow wire, which we have at that interface between the photoresistor and the 10 kilo ohm resistor, this is going to be measuring the voltage drop across this resistor here. And the voltage across this resistor is going to change as the resistance of this photoresistor changes. And it's fascinating to me. The resistance changes a lot just if I move my finger over it. Because the resistance changes as a function of the incident light on that surface up there. So, here we go. So basically, this is reading the voltage from that yellow jumper wire, which is the voltage drop across that resistor. And this is going to change. Now, the analog read, we talked about analog to digital conversion in class, but it's going to convert that voltage, which is going to be somewhere between 0 and 5 volts. It's going to convert it first to a string of 10 binary digits, so like 1, 0, blah, 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 blah. But then it converts it to an integer and spits it out to the serial monitor if we use this serial print command. So let's upload it. Uploading. Done. Great. Now once it's uploaded, go to the tools and then go down to serial monitor. Now here's what the serial print command does. Maybe if I can move this out of the way a little bit. So serial print, it just prints out this text. How many times per second does it update? That's a good question. I don't have a timer in this void loop, which actually calculates how many times this iterates. If I had to guess, this would be somewhere between a millisecond and a tenth of a millisecond that it's iterating through this. It's very fast. So something around like 1,000 times a second. And if we increase this baud rate, it can send data to the serial monitor even faster. So this number in here is called the baud rate, which is how many bytes per second. And a byte is 10 bits, right? So if you think about it, like each integer is that we print here is 10 bits, so it's like a byte. And then I don't know how many bits it requires to print this text every line. Maybe more. But then I'm doing 9,600 bytes per second. And if you look down here, this button, it lets you select the baud rate. So this has to be consistent with the number you chose in here. So like, if you look at this, one of the options, I opened the wrong code. One of the options, I could go to like 57,600. How about we select that? So if I select that right now, it'll give me junk in the serial monitor, and that's because it doesn't match here. But I could change this 57,600. If I upload this again, the serial monitor is going to work, and I think it's going to be updating faster. Yeah, it's going out of control. It's also cool to go to the serial plotter, which just graphically outputs the same information as the serial monitor. So if I wave my hand over this, it's those same integer values. If you look at the X, Y, if you look at the vertical axis, it's some integers. And as I wave my hand over the photoresistor, I see it changing. Really cool. Okay, so let's change this back to 9600. Upload this. And then I gotta change my serial monitor back to 9600 so that it will actually work. There we go. Let us go back. So higher the number, the higher the frequency. Yes. Yep, you can pump up the baud rate to increase your sampling frequency. Where are we? Okay. Okay. So, this first exercise, I guess that's basically it. The first exercise is just uploading that code and then just playing around with it like we just did and seeing how the values change. There's not anything else in there, right? Okay. And this will be important later because exercise 3, we're actually going to turn this into a circuit that does something. If there's less light in the room, we want the photoresistor to detect that and then turn on an LED. So we'll need to know like what kind of value corresponds to being in darkness. I have like a bright light shining on my circuit right now. Okay, let's move on to the next one. So this one, you're gonna modify that code. And what are you gonna be modifying? I want it so that the signal voltage in millivolts, yeah, serial plotter is really sweet. It's very, very cool. To see how sensors are just updating thousands of times a second, getting these readings. There's so many projects you can already do just with this. So I want you to output the signal in voltage in addition to the ADC value. Now we won't spend time on this here because it's really straightforward to do. Let me tell you what you need to do. You got to go back up here because I give you a sample code that does exactly what I'm asking. Basically, this is the conversion. Each integer that comes into the serial monitor, which is going to be between 0 and 1023, if you multiply that by 4.88 millivolts, it converts it to a millivolt signal. That's just according to the resolution of this board, which is 10 bits. So basically, you just need to add these lines of code, and you should get that updated. Now, also notice the distinction between print and print line. So print line, it'll print the argument in parentheses, and then it'll go to the next line. So like if we remove print line, maybe we can do it in the other code. You'll see what happens. So I'll close the serial monitor. I'm gonna open up this code. What if I remove the line? You'll see now that it just prints all the data in a row. It never goes. Let's just show you. So it just prints data this way. Just constantly, it never goes to the next line. So it's important that we add these characters to make it jump down to the next line. And now it does that. Okay. So let's move on. Okay, the next exercise is fun. We want to add our LED to this circuit. And basically you want to do what's shown in this picture. If the light is on in your room, then this LED should be off. If you turn off the light, the LED should be on. Okay, how about we just build that portion of the circuit? Let's add an LED. I'm gonna use whatever drops out of this bag. Happen to be green. Remember, the long leg of the LED is the positive end, and it does matter the orientation here. So I'm just gonna kind of randomly plop this down on the board with the positive leg up top. And then I'm going to take an orange wire from digital pin 13 over to the positive leg. Okay. And then we need a 1 kilo ohm resistor. Now remember, these can be a little tough sometimes to get into the hole. So like, we had a great suggestion, which is like, I know I want to put the resistor in this hole right here. So first I'm gonna take a jumper wire and kind of drive it in a couple times and it loosens it up. Oh, actually, oh, I don't know if this happened to any of you. I just broke the jumper wire, like the end came off. Not cool, man. That wire's done. All right. Broke one 5 minutes ago, says Drulish. Ugh. Not cool. Okay. Okay, so I got this side in. You know, I'm just gonna try this other one without priming the. This is probably the most challenging part. All right. Invest in a small set of needle nose pliers. Is that just for extracting? Oh, for helping push it in, right? Because I guess you can clamp the side of the wire and... Oh, that went in nice. Okay. How do you show the graph again? You go to Tools. Let me show you. You go to Tools at the top, and you go to Serial Plotter. So it's right beneath Serial Monitor. Serial Plotter, yep. All right, we got the resistor in, and then we're going to take the other end to ground. Wow. Got it. So now we have the LED in there. Okay, so you heard the goal. We want to turn this light on if the light in the room is off. So, I mean, just the fact that I use the phrase "if" there is a clue. If the reading that I'm getting from the photoresistor is above some threshold, so the value gets higher the more light there is, right? Let's go over here. Sounds like an if statement. Exactly. Like if we upload, oh, I already uploaded this. So let's just go to the serial monitor. So right now I have like an overhead light on the circuit, but if I turn down the light, you see this number going down. So it went down to 600, and then I have like another lamp. I have the computer screen. What if I turn off the lamp? Still 600. Oh, because this overhead light is just a lot. What if I turn this off? Oh, buddy. Okay, so you see what's going on here. So you make an if statement. You say, if the reading is less than something, and it's going to be different for all of you, depending on your lighting conditions, then you should turn the LED off. If it's greater than that, it should be on. Let's turn the slide back on. My threshold value is 100. Yeah, so it'll probably be something around that for all of you, like 100, 200. And it's cool. Like once you upload that circuit, you're gonna see that this thing is gonna react in real time to what you're doing. Actually, maybe off screen. I'm not gonna show you my code, but I think I have it like primed. I could just upload it and you could see how my circuit reacts. Where are you? So what if you get a small ADC reading, even if you are absolutely beaming a flashlight at it? I think that means that it might not be plugged. You might have the wrong resistor. Like, are you sure that this is 10 kilo ohm? Like not 1 kilo ohm, like, because that'll change the sensitivity significantly. Don't we have to set the output for, oh yeah, if you use 1 kilo ohm, that'll throw it off. Put the 10 kilo ohm in here and your sensitivity is going to be way different. Yeah, you're going to have to change the output for pin 13. Because that's the one that's connected to the LED. I gotta close this. You're very welcome. All right, let's turn off some lights. What do I set my threshold here? Ooh. What if I turn this off? See? It reacts like immediately. So that gives you a clue of like how quickly your void loop is running. I mean, it's assessing this if statement, and so I'm gonna change this value a little bit. Maybe upload that. And you can play with the values. Aren't we independent to use any port, or do we have to use 13? No, you could use, if you want to use a different port, that's fine. And yeah, I would play around. Like right now, all I'm doing is I'm tweaking the threshold for my if statement, and then I'm running it again. So now I'm changing the overhead light. And it's turning on and off. So it's pretty cool. Can the if statement be anywhere in the loop? Yeah. I think there's different places. I mean, it definitely has to be after you get the sensor reading, right? So in the loop, you read a value from the sensor. Wait, maybe I'll pull this up. Like the first thing we do in the loop is we get a reading from the sensor. Then after that is where you put some conditional if else logic or whatever to be like, well, okay, if that value is greater than or less than this or whatever, then turn on or off the light. It'll feel satisfying once you get that running. But the next one might even feel more satisfying because there's more options. Let's talk about the next one. Unless you guys have more questions about that one, I'm gonna move on. We're gonna build this next circuit. Oh man, this might be a little bit of a pain just because because there's a couple 1 kilo ohm resistors here, and we have to plug all of those in. I'm gonna get rid of this text at the bottom of the screen. Okay. I think if statements should usually be in the loop. Oh yeah, they'll be in the loop for sure. All right. I'm gonna break up this circuit. You know what though? I'm gonna remove the photoresistor and all of this stuff at the top, but then I'm gonna just start plugging in LEDs. And I'm gonna unplug my USB. So this is unpowered now. Should I unplug the board every time I go to hook something up, or it does not matter? Nick, I would say it depends on the application. For this, we're just turning on and off lights, and we're not driving any like high power devices. I think in general, it's good to, if you're adjusting the circuit, to unpower everything and then adjust it. But what we're doing right now is pretty low stakes, so it's probably okay to leave it plugged in, but... Alright, so all of the stuff that went with the photoresistor, I'm unplugging it. We can leave that ground cable plugged in. Alright. So we need 4 LEDs in here. Back to the electronics cam. Let's plug in some LEDs, people. Do some different colors. I'm gonna do a red one at the top. If you really get into this one, yeah, this one's really sweet. You can plug in as many LEDs as you want. Like I've done this before where the LEDs, like I probably have, 6 or 7 on each side, and you can just like run around. Or you could have many LEDs for the previous exercise as well. Okay, so I'm gonna have pin 13 go to this one. You need a different digital pin to power each of these. All right, where's my one? I need another 1 kilo ohm. Okay, fortunately that went in pretty easy. And so did that one. Maybe I've used those ones before. All right, and then I'm gonna send this end to ground. All right, and then I got this second one already in here. Oh wait, so I'm gonna take the high end, the positive end of this LED, and I'm gonna put it on digital pin 12. So it's just got a different digital pin going with it. All right, next color. Let's do yellow. Did you know we have LED emotes in the chat? Let's try this. Yeah, so like if you type LED yellow, LED red. Okay, so we got this. Let's put in our resistor. There you go. I think we have blue, we have green, we have white. There's options. Okay, that went in pretty all right. Do you know if they sell assorted length male wire connectors? You're talking about these jumper wires right here, Phil? They definitely do. This exercise will be lit. I see what you did there. I see what you did there. You made a pun. You should feel ashamed of yourself. Okay, so I got that LED in. We're looking good. I'm gonna connect the high end of this LED to digital pin 11. And then we gotta remember to connect this to ground. With this exercise, I fear we are being LED astray. Oh my gosh. Toasters, are you kidding me right now? No purple? I guess we did. Yeah, we don't have all the colors. You guys and your puns, are you kidding me? Okay, we got 3 LEDs. We got another one. We must resist the urge to be lit. Wow. All right, I'm gonna do blue for my last one. There we go. Another 1 kilo ohm resistor. At least I didn't lead you on. God. Unreal. Okay. I don't think I've used this end of the breadboard as much, so I'm expecting these to not be as agreeable. Okay, I'm gonna try using a jumper wire to open up this one a little bit. Okay, it went in easier. Then I'll do the same with this. Okay. Whew! That's the last resistor that we have to do tonight. All right, so we'll connect this end to the ground, to that ground column. And, oh shoot. Oh no, that's fine, that's fine. I thought I'd plugged the resistor into the wrong, but it's okay. Yeah, that's okay. All right, and then I'm gonna take digital pin 10 and send it to the positive side of this LED. And we have all of our LEDs connected. 13, 12, 11, 10. Those are our digital pins. All right. So now we're going to use the potentiometer. So in your kit, you have to find your potentiometer. It looks like this. It's got two pieces. The bottom piece, it has these. Come on, focus. You can do it. Maybe I have to clear the background for it to focus on this. Yeah, it says B103. It's got 3 leads on it. And then you can hook up the dial in there and you can feel it rotate. It has some resistance to it. Now what's going on in here, there's basically a resistor that's shaped like a disc in there, and when you change this dial, it slides a metal contact around that disc. And that's where the current flows through, kind of like that metal connection point. So depending on where you are, the current has to travel through a shorter distance of the dial. And that effectively reduces the resistance or increases it. Like if you have to travel the whole length of the disc, the current, then it's going to have more resistance to work through. So that's how it works. It's got a variable resistor in there, essentially. So we're going to have to hook this into the board. Let's go back to our schematic here. So it's down here at the bottom. And that's a little pixelated. But you can see the 2 legs on one side, they're going to be on this side of the breadboard, and the other lead in the middle is going to be on the other side. So let's try to connect it somewhere down here. So I got the 2 leads. I'm going to stick them in on one side, and then the other lead is going to be like, I think 2 columns in on the other side. Let's see. Let's just try it. I remember this being a little difficult. It doesn't go in easy. Like you can see mine's not... I'm not totally sure if it has a solid connection right now. If anybody comes up with a good strategy for this that they can share with the class, that'll make me very happy as well. Because I don't have like a great tip right now. I think you just have to work with it. So when you turn it, it changes the resistance? Yes, that's exactly right. Okay, let's just, I don't know if it's totally in, but we'll just assume the best. All right, so we'll go back to the schematic right now. So this bottom leg, it's gonna go to ground. So I'm just gonna use somewhere here and then go to ground. The top leg is going to go to 5 volts. Well, we have a RAID. Would it be difficult to output a numerical display from the potentiometer, like just as a way to see if it's working properly? No, that's totally what I plan plan to do, Toaster? Hey, Disc 1 of 5. Welcome to the channel. All right, let's send this. So the top leg of the potentiometer, that's going to go to the 5-volt source. So like I'm going to use one of the longer red wires because this is going to have to travel a longer distance. Okay, so I got that in, and this is a longer red wire. It's going to go all the way over to the 5-volt pin, so you're going to need the longer wire. And you can see it's in the 5-volt over there. So basically we're, so if I hook up a 9-volt battery to the Arduino, does my Arduino still only give off 5 volts? Like, does the controller board tone down the voltage somehow? Now, okay, so here, Disc105 says, I'm always scared when I'm doing projects, my gauge of wire, never too sure when a wire becomes a heating element. Yeah, so fortunately, we're not drawing much current here yet. These little jumper wires will do. But yeah, so T Jackson, we know we can plug in like a 9-volt battery here. This 5-volt pin will still output 5 volts. Now there's a V-in pin. This one, we can actually get more voltage out of that. I need to check this again. I don't know if you plug in 9 volts here, if the V-in pin will now output 9 volts. Or, yeah, I need to check that. But you certainly don't have to worry about the 5 volts changing. BGK says, doesn't matter what color I use. No, the color of the wire doesn't matter. So really, you can choose any color you like. Now there are some conventions though, just so, like if you have a bunch of wire, it's useful to like have red mean power, and usually black or sometimes brown, sometimes blue, those mean ground. So like my convention, just so I keep track of things myself, I use red for power, blue for ground, or maybe black. And then for like signal or output, I use like different colors. So like for these LEDs, I'm using like orange, yellow, green, yellow, whatever. Okay, so we have one more pin on the potentiometer that we need to connect, and it's this third leg over here. And you're gonna have to use another long wire. I'll just use a green one. And it's gotta be in the same row as this third leg. Put it here. And I'm gonna drag this over to A0. And then we're gonna check if this potentiometer is working, cause, so yeah, I put the other end over here, A0, cause we're gonna be reading that analog input. All right, I'm gonna run the same code that we've been using from before, because our old code used pin A0, and so now we're gonna use that pin again to read data from this potentiometer. And we'll see if it's working. We'll see if it's working. Okay, so I already uploaded it. Let's go to the serial monitor. Wait, am I using the right code? Oh, I think I need to change it. Okay, so serial monitor. Okay. Now I'm gonna turn the potentiometer. Ooh, you see it's changing. So I turned it all the way to the right and it went to 0. Now I'm turning it to the left. And it's increasing, and it goes to 1023. So if your potentiometer is doing this, it's changing its signal as you turn the dial, then you know that it's working. And like I said, all this is doing is it has a little resistive element in there. It's shaped like a disc. And this dial is just moving a metal contact along that disc. And it's changing the distance that current has to travel through it. So it's effectively changing the resistance across it. You could go to the serial plotter. Boom. And you can see that value changing as I turn the dial. Okay, now here's the goal of this exercise. You want to, like you can see that this dial, it goes up to 1023 when I go all the way to one side. And then when I turn it all the way the other way, it goes to 0. So what I want you to do is divide this range into 4 equal regions. And somebody was asking earlier, like, does it have to be decimal precision equal? No. But the idea is that as equal as you can get it using integer values. And depending on where it is in like those 4 equally divided regions, I want you to turn on one light at a time. And you can already imagine it's going to be if statements, if else, else if. You get the drift. If you go into the workshop, there's a snippet here that shows you the syntax of how you can use that. Something like this. We could use this to set the threshold from the last exercise. Yes. Yes. So this is how you do it. So like inside these statements, you're going to be turning on some lights, turning off others. You can sketch you could do like an etch and sketch. I guess you need like 2 dials though. You guys know etch and sketch, right? Okay, I'm gonna see if I have some code on hand that I can show you how this works. Because it looks very cool. When you get this thing ready to go. Like I said, you can add more LEDs if you want. Okay, let's upload this one. Just to be clear, that else if statement is just saying if that first condition doesn't match, then it can go to the next condition. Yeah, let me open up that code again. So what this is saying is if this reading is less than 500, then do this. But what if it's not less than 500? So if this statement isn't true, well, if this statement isn't true, it goes to the next one. So it says, okay, well, let's try this next. Is this satisfied? So this is saying if it's greater than 500 and less than 750. Is that true? Well, if it isn't, then we move on to the next. So it goes through in sequence, and the first option that's true, it's going to do that. All right, I gotta close this. Let's upload this. You're very welcome. Is this gonna work? Oh, buddy. I need to zoom out a little bit here. I think it's jumping around a little bit because my potentiometer is not super secure in there. The connection's a little poor maybe, but you get the idea. Oh, this guy's not plugged in there well. I'm turning it one way, then the other, and you can see it's fast. You could add as many LEDs as you want. I mean, and these potentiometers, like when you're using your guitar amp, this is all that's going on there. We're setting it to different settings. When you do different air conditioner commands in your car, it's using a potentiometer. So it's just, it outputs a different voltage, and then we can have some logic that changes the output. And my friends, that is it. And we'll see how this looks with the lights controlled. So gotcha. So how does it work exactly? Do different LEDs have different resistors with them? Boom, 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 boom. Wait, what do you mean? Is it okay that I use different colored LEDs? Yeah, you can pick whatever colors you like. You could even have them all be the same color. I'm guessing that you can put other things in place of LEDs if you wanted to, like a servo. Yes. Yeah, remember, all that the output pins are doing is they're on, and so they're providing 5 volts of power, like up to like 30 milliamps of current. So the thing is, though, the Arduino outputs very little power. So I think it's the next workshop, actually, that we'll talk about how you can do this with higher power devices using a relay. Yeah, flowers, that's a great response. So how does it work exactly? Do different LEDs have different resistors with them? Yeah, so different LEDs are connected to different output pins. Oops, sorry for blinding. You can see that each LED is connected to focus. Yeah, pin 13, pin 12, pin 11, pin 10. Each LED has its own. And I'm just turning on each one, but you also have to turn off the others. Explicitly to make sure that they... Boom, boom, boom. Yeah, but that's what's cool. You can substitute in many different components here. Ooh, I just had an idea. Like this potentiometer, we could replace with the photoresistor circuit that we used earlier. Wait, that wouldn't be too hard to set up. Heck, I'm gonna do it right now. Watch this. We're gonna take this guy out. Oh my gosh. Oh my goodness. Maybe I'll unplug this for a second. Will workshops continue to be due every Friday? That's the plan. We're just gonna keep rolling with these. We're gonna keep accumulating more fantastic skills. All right, I'm gonna put this photoresistor over here. Come on. Oh man, this is not gonna do it, is it? Okay, one leg went in. That's success. I think the other leg went in. And then we need the 10 kilo ohm resistor, which I believe it's this one. Come on, my friend. Good. And I need to put this sensor in the middle of this voltage divider. So that jumper wire is in that same row where the photoresistor and that edge of the resistor are connected. I got the power that needs to go to the top of the photoresistor, and then the ground needs to go to the bottom of this resistor. Oh, we're gonna plug back in this. We're gonna plug this back in. What if I change the light? Oh my goodness. Wait, what if I use the flashlight from my phone? Yeah, so I mean, you can substitute any sensor because all it's doing is outputting, you know, a different voltage. You could use a sound sensor, and that's how you can make like you know, basically like a decibel monitor for your music. Humidity sensor, yeah, or just like a temperature sensor. You could have some LEDs letting you know, like, hey, it's pretty hot outside. It's pretty cold. Like, think about this. You could have a blue light that's saying, like, hey, it's freezing outside. You know, like Wegmans parking lot has, I think they have a sign that it's like, if this is blue, then it's freezing right now. But I mean, you can do that electronically. Uncle Bill Druin dropping in. Welcome. We're just doing some Arduino sensing and input output actuation. But yeah, that's why I think this workshop is pretty fun. We'll just keep learning more and more stuff, and you can do more and more different projects with it. But that's all I wanted to cover with you guys. I always have a lot of fun hanging out with you, whether it's in class or doing these workshops. It's especially nice during these COVID times where we don't get as much interaction. And this is something we can do, and we're learning, we're interacting, we're making progress on our schoolwork. It's all good stuff. What kind of a sensor would be used for that temperature thing? Every LED pin had a code in the last workshop. We actually have, I think, multiple temperature sensors in the kit. Let me check something here. I'm gonna turn on a light though. One thing we have in the kit is called a thermistor. Let me see if I can find it. Well, like, excuse me. This thing is a temperature and humidity sensor, but it has like its own onboard circuitry which processes the measurements a little bit differently than what we're doing with this photoresistor. So this is actually a little more complicated, and it has its own like programming on here effectively. But so this is one thing you can use. But there's another thing I want to show you. I haven't used this yet. I don't even know if I can get it out of the bag. It's a thermistor. It's a resistor that changes its resistance with heat. Would a gyroscope be considered a sensor? Yes, a gyroscope is certainly a sensor. It measures the angular rate, the rate at which something is rotating. This kit doesn't have a gyroscope. It doesn't have an accelerometer. I wish it did. Those are really fun to play with. There's a tilt ball switch. That's true. Where's that thing? It's actually this guy right here. And you can hear the ball like rattling around in there. And when you, there's a little ball in there. Wait, you were looking for Workshop 1 on YouTube and couldn't find it? and workshop 2. I think it is. I think it. Oh, workshop 2. No, I haven't put up workshop 2. This is gonna go up to YouTube though. Right after I finish this stream, it'll be, well, it's automatically on Twitch, and then it, I upload it to YouTube, and that'll take a couple minutes too. That's it for tonight, everybody. I hope you enjoyed it. I hope you're enjoying the workshops. Could you go over how you did 2.3 again? What was 2.3? Oh, no, I'm not gonna go over that again. You can come back to the video if you missed it. You can rewind, you can watch as many times as you want. For example, red was 10 when we introduced it, 13 for green, and what would it be for yellow and white? We're talking about the LED, like, it doesn't matter. I don't know if you're asking about, does the color of the light matter which pin you use? You can plug in any colored LED into any pin. So it really doesn't matter. Will we end up using everything in the kit by the end of the semester? We won't use everything. We won't use everything. But you can always use whatever you want. I mean, the goal of this class is to give you all these skills so that basically you could look at anything in this kit and be like, ah, I can handle that. I can handle that. All right. Any last quick questions before I sign off here? Boom. I'm gonna start disassembling some of this stuff. Or maybe I'll just leave it. Can we buy different sensors externally and use it with Arduino? Yes. That's the beautiful thing. Like accelerometers, gyroscopes, GPS, man, all of that stuff you can directly interface it with the Arduino. Very easy to use. Plug and play, just like this stuff. Bluetooth communication. There's Bluetooth modules you can use. There's different, so just like there was this kit, which has a variety of things, they have some Arduino kits that are exclusively sensors, and they have like 50 sensors in there. It's probably like 20, 30 bucks. Yeah, I mean, if you start enjoying this and getting into this, I advise go to YouTube, look up different Arduino projects, and a lot of them tell you like, hey, these are the parts we used. And it's all used the same way. There's no like mystery to it. And so I would take on a pet project and just run with it. It's a lot of fun. A hot tub controller. Very nice. All right, everybody. That's it for this evening. I'll see you on Friday. Or in office hours. That's also a possibility. Have a good night. Bye-bye.